Okay, so what we're going to do in this short video is just recap on what we covered in the first video. We're going to take a look at the meter here and connect up to it, and we're going to try and simulate an on-off signal from the meter. So remember, to measure voltage, we connect the meter in parallel. So we're going positive and negative, and we'll get up our voltage on it here. So 11.36, and if we say took it off, it will drop to 0. On. So if I try and do it a little bit quicker, what we'll see is our voltage is all over the place now on our meter because the meter can't actually keep up with how quick it's changing. So we're going to take a look at that and try and simulate it on the oscilloscope here again. Now, again, our two leads coming from our one lead, our blue lead here. One is definitely always going to be earth, we said, and we're going to click it onto earth. And we're going to run the oscilloscope here and start what we just did. Are we running? No, we're stopped. So we're running it. So again, our earth is switched on. We touch on here and we see we're gone just up to our approximately 11 point whatever it was on the
spread out the time.
So we see our time scale is set up at the same and our voltage is set up at the same. So we're getting what we saw on the meter there now, right? Exactly what we saw when we were connected. Now the difference being, if I watch it, disconnect it, we see it falling and going back on, like we were with the meter, nice and slow.
2 to 3 seconds.
So if we were to do it like we did where the meter was getting confused because it was actually changing too fast for the meter, we can simulate that, but we will be able to see our on-off signal now from the oscilloscope. So again, we're going on here now. Now remember, where we probe with the oscilloscope is important. So when we were doing our basic electricity, nearly all of our switches were on the power side. And what we'll find is with most cars with electric circuits or electronic circuits is they are mainly switched on the earth side. So we would normally probe on the earth side to pick up a signal, because if we probe on the positive side, it'll be a constant positive and we won't see any change happening to that 12 volts. But we will on the earth side, because when we're on the earth side of the circuit, we go from battery to load, and now we're probed on the earth side, but the switch is open. So we've an open circuit now. And when we have an open circuit, even though I'm probed on the earth side, because it's earth switched, I'm actually on the power circuit, which is what we're seeing now. So if I come off and then back on, you see it switching on there. And if I do it very fast, we can see a pulse waveform for on-off. Again, off, back onto a steady voltage, and then a slow off, on, off, on, and we see it produces a square waveform. So again, if I on off quickly, we get a pulse factor happening there. So we'll just stop it again on our oscilloscope, and we should be able to step back through the frames. There's our signal, our on-off signal. So, what we're going to do now, because we can see it on here, is really explain this on the whiteboard, what's happening here. Explain what we can see here. So if we swing over here to the whiteboard, what we've done on this is we have set up our oscilloscope just in a freezed frame here, right? So we can see our voltage here is set up here. So we're going from 0 to 5, to 10, to 15, to 20, to 25. And in between here, because there's 5 volts between each one of these lines, we put in, so 10, 11, 12, 13, 14, and then we hit 15. You may not be able to see that on the oscilloscope screen on the video, but that's exactly what I've done here. And then we have our time scale lines across coming vertically down, breaking up our time scale lines is over there. So let's just draw a waveform as we see it on the screen up there. So we started and we said we had approximately 11 volts, a little bit more, so we will be starting here. There's our on, and we're constantly on. Now, when I break the circuit, we immediately drop here, down to 0. Stay at 0, we reconnect the circuit, we come back up, and off we go again, and then we pulse it. So we got these pulses here happening between on and off. So, I was switching from the positive side of the circuit there. So we saw on, when I broke the circuit, we saw off, same again, on, off. Now, on a circuit where it's earth switched, this actually up here would be off, because remember what I said, if we're probed on the earth side and it's earth switched on the circuit, we're actually connected to the positive side of that circuit when it's off. When we turn it on from the earth switch, we come back here and we're on down here. So, if you remember in basic electricity, we checked for voltage drop across consumer, the light bulb or whatever it was, and we were saying we were going to use that as a voltage drop test to see is it working or not. Here is our voltage drop, right here, from here down to here. So we were off here, circuit switched off, and the earth switch is in an open position. Then we connect the circuit to earth, which means because we're probed on the earth side, where our probe is suddenly became an earth. But that is actually on for us here. So we're on here now when we're dropped down here. Again, we broke the circuit, so we opened the switch on the earth side, which meant our probe is still connected. And now we're back onto the positive side here, and off we go again. And we see on, off, on, off, on, off. Basically, on circuits, even if you forget this little bit of which is on and which is off, for us, when we want to see is a signal there, we're getting an on-off signal. Even if you forget which is off and which is on, once we can see a switch taking place, we know that something is happening. It's switching on and off, right? So if you forgot and said this was on and this was off, technically you're incorrect, but for what we're doing in workshop practice, you're looking for a signal. You're looking that it is actually switching from one position down to another and on and off and on and off and on we go. So we also said when we're connecting up to a car that we would back probe, right? So remember we said we had our needle here, right? And we said we would back probe in. Now if we can zoom right in on this, we can see we've 3 wires here. And right here, let me bring it off a little bit. We can see our 3 wires still on the connector. So if this was a component and we were back probing for it, we'll pick the middle one because that's the signal. And you can see this here is a moisture stop, right? To stop moisture getting in there and corroding the actual pin. So we don't want to damage it, so which is why we use such a fine needle to get in here. And we actually slide it down the side between the insulation and the wire itself. And we should be connected to the pin at that stage in the game without damaging the insulation. Because we don't want to damage the insulation, because if we're probing this to find out if it's working or not, and it is working, what we don't want to have done is damage the insulation and actually cause a problem. So where moisture is going to get in there eventually and then cause a bad connection on the pin itself. So taking your time with back probe and stuff like that. Now you see people that if you don't have these actual probes that plug in here, remember, because these all plug into the actual lead for the oscilloscope, people would use paper clips. So anything that's really fine and small that we can slide in along that insulation and wire is fine to use. Some people used to use nibs off needles to slide it in the side, but anything at all that you can do that's not going to damage that insulation. We also, while we're on the topic of it there, we'll see, you sometimes see people stabbing into the actual wire itself to get a signal off it, which is fine in some cases, right? But if you probe into a wire, you broke the insulation out. Now, in some cases, you will have to do that. But what you have to do is seal it again, because you can put moisture or put a hole in and allow moisture to get in there and cause a corrosion inside the wire itself if it's left unsealed. So using something like heat sink on it to afterwards, so cut the heat sink, wrap it around and just heat it up and get it to seal around that wire again and try and keep the moisture out is an important factor. Okay, so that's just backed up what we said on the video, the first video, and we just wanted to give people a quick look at what things on a whiteboard, what it looked like, so as we can understand what's happening on the actual screen in front of us. In our next video, we're probably going to set up and take a look at some ignition stuff, which we've already talked about. So we're going to start possibly with the kettling system, the old points and condenser system, just to give you a visual on what's happening mechanically with it before we get into, and we can still produce waveforms from this mechanical stuff, before we get into more modern stuff like coil and plug or waste and spark stuff. Okay, that'll be covered in our next video. Thanks.